So please note it down. The next heading, for a system of n interacting point charges. Point charges, electric potential, at a point is algebraic sum of potential due to individual charges. Okay. You can consider here a number of charges, like this is your charge Q1 and this one is of Q2, and the third charge we have taken, right, Qn, and we are choosing any point P here, and we want to calculate the electric potential due to all of 3 point charges interacting at point P. And now, first of all, you can meet all of the charges to the point P like this. And by doing this, you will get the separation from the point P to all of the individual charges. Like you can write here, this is your R of 10, this is R of 20, you can take it as O, and this is your R of N0. Okay. And now, can anyone tell me what will be the total potential at this point? Nawal, can you tell me what will be the potential due to the point charge Q1 at O? Nawal. Hello.
Yes, sir.
Yeah, can you tell me what will be the potential at O due to charge Q1?
Q by 4 by epsilon 0 R.
Q by 4 pi epsilon naught R10, right? Okay, good. Why? Because Q1 individually behaves just like a point charge. Are you understand or not? So we can write here. Sorry. Yeah, so we can write here V1 is equal to Q over 4 pi epsilon naught R of 10. And just similarly, there is no any impact. There is no any effect is observed due to the presence of the all other charges. Are you clear or not? So we can write here due to the potential, due to the charge Q2, your potential will be V2, and we can write here, this is your of Q2, 1 over 4 pi epsilon naught R of 20. And similarly, for NH charge, you can write Qn over 4 pi epsilon naught R of N0. Are you understand?
Yes,
and now, according to the statement, you can look on the statement, electric potential, 1 second, your electric potential. What is saying here? Algebraic sum of potential due to the individual charges. All right. So we can write here the total potential. We can write total potential V is equal to, just like an algebraic charges, algebraic sum of the all potentials. We can write V1 plus V2 up to the Vn. Am I right or not? Are you understand?
Yes, sir.
Okay. And now, what is your value of V1? Your value of V1 is your Q1 over 4 pi epsilon naught R10. And V2 is Q2 over 4 pi epsilon naught R20 up to the Qn over 4 pi epsilon naught Rn0. Are you understand? And now similarly, you can take here 1 over 4 pi epsilon naught as a common. Okay. And you get in bracket Q1 over R of 1, 0, Q2 over R of 2, 0, and up to the Qn R n 0. Okay. And now mathematically you can write here, this is your algebraic sum of Q1, Q2, okay, up to the Qn. So we can write here in algebraic form summation of I. We can take here I. I is your from 1 to the n. Are you clear? And we can write Qi over Ri. Are you understand or not?
Yes, sir.
Yes.
And this value of I, you can take from 1 to the nth number. Are you understand? So this is your final potential at point P due to all of these individual charges. Okay, algebraically. Okay, this is the equation of total potential at point P in algebraic form. Are you understand or not? In algebraic,
Yes, sir.
because this notation is used in algebra. Are you understand? So please note it down. Then we will see this equation in terms of the calculus. Are you clear? Please note it down. Nawal, it is clear or not?
Yes, sir.
Okay, good. All of you have noted it or not?
Noted.
Can we move on?
Yes, sir.
Yes, sir.
Okay, okay. So we have seen the equation of potential at point P due to all of these individual charges. And now, what will happen if your charge distribution is continuous? Okay, you have already know for the continuous charge distribution, we can write V is equal to 1 over 4 pi epsilon naught integration of dq over dr. Note it down, please. This is your equation in terms of calculus, okay? And generally used for continuous charge distribution. Have you noted it?
Yes, sir.
All right. Now, what will be the equation in terms of position vector? If you want to write it, then you can note it, please. Potential in terms of position vector. In terms of position vector, right? You can draw your coordinate frame first. This is your coordinate like this. And yeah, there is a charge placed in the first quadrant. This is your charge placed at here. Okay, and we want to calculate the potential at this point P. Suppose that this point is point P. Okay, first of all, you should join all of these points from the origin. Then you get the position of individual points. And now we can write here, this is your position of R of Q, you can say, and this is your R of P. Okay, I mean position vector of P. I understand. Then when you go from Q to P, then you get, this is your R QP. I understand. And what is your R QP? One second. It is not clearly seen here. R QP. Okay. And now, can you tell me what will be the equation of the RQP? How can you write it? Your RQP can be written as RP minus RQ. I understand. I hope all of you remember from the previous classes. Okay. We have seen this equation many more times. Do you remember or not?
Yes.
Yeah. So what will be your position? Potential. This is your 1 over 4 pi epsilon naught Q over RQP. Okay. And now this RQP can be written as V is equal to 1 over 4 pi epsilon naught Q over, you can put RP minus RQ at the position of RQP, right? So you get RP minus RQ. It's okay or not? Nawal, it's clear?
Yes, sir.
Yeah, note it down. Have you noted it?
Yes, sir.
Good. And now we are taking an example to solve, to understand it. And this example is based on the position vector. I mean potential in terms of position vector. Okay. So please note it down. This is your question. Three charges Q1 is equal to 1 microcoulomb and Q2 is equal to minus of 2 microcoulomb, where Q3 is minus of 1 microcoulomb. Okay, are placed at A. A is 0, 0, 0 at B, which is minus 1, 2, 3, and at C, which is 2, minus 1, 1. Find potential at P, which is minus 1, 2, minus 1. Okay. This is your question. All right. And now please try just one second. Please change in change this notation. This is not Q1, Q2. This is your QA, QB, and this is your QC. Okay. And now please note it down and try to solve it. All of you can solve it. Matthew and Nawal. Matthew. Nawal, can you tell me which one concept is okay applicable in this question? Nawal, can you tell me please?
Yes, sir.
Which one concept, which one equation is applicable here?
One by 4 pi epsilon 0 Q1
Okay.
by R10 plus Q2 plus by.
No. I mean you are. You means you okay potential in terms of position vector, right?
Yes.
Equation of potential in terms of position vector, all right? Because you can look in this, your position vectors are given here. Sorry, your positions are given here, like A in terms of A, B, and C. Are you understand or not? Okay. So this it is clear that the concept of position vector is applied here. And now, first of all, before solving, first of all, we should write your position vector first. Okay. So you can write here, what is your position vector of A? A can be written as RA. Okay. RA, which is a 0, 0, 0, 0. 0, 0, 0 in the sense 0I plus 0J plus 0K. Are you understand? And now similarly, what will be your position vector of B? Can you tell me, Nawal, please? What will be your position vector in case of B? You
minus 1I, 2J,
minus 1I plus
J plus
2J
3K.
plus 3K. And now position vector of C. Tell me please. Yeah, tell me please, Matthew. What is your position vector of C?
So it will be 2I cap minus
Minus
1J cap.
minus J, right?
Yeah, J
And
plus K cap.
Good, good. And now some other information. Okay, some more informations are given here, which you can look at here. Q1, Q2, and Q3, right? And now all of these values are given in terms of microcoulomb. Are you understand? So we can write here your QA is 1 microcoulomb. And first of all, you should convert it in the terms of coulomb unit. You can write 1 into 10 raised to the power minus 6 coulomb. Okay, Nawal, are you understand? Similarly, your QB can be written as, first of all, what is your QB? This is the minus of 2 microcoulomb, which is minus of 2 into 10 raised to the power minus 6 coulomb. Similarly, QC. QC can be written as minus of 1 microcoulomb, which is your minus 1 into 10 raised to the power minus 6 coulomb. Are you clear? I means all of the informations given in these questions, okay, we have already written in the proper form, okay, which is directly used into your concepts, okay. And now, how can you calculate the potential at point P? It is saying here at point P. Your point P can be also written here RP as minus of I cap 2J and minus K, okay. And now, can you tell me what will be the total potential due to all of these three charges? First of all, we can write here the total potential can be written as V is equal to V1 plus V2 plus V3. Are you clear, Nawal? Why we are taking here three potentials in this equation? Nawal, why we are taking here three potentials in this equation?
We have 3 charges.
Exactly. We have 3 charges and at 3 different positions. Okay. So what is your V1? V1, 1 second. We can take this equation directly, or to short this solution, you can choose this equation. Are you understand? Okay. we are going to take 1 over 4 pi epsilon naught as a common. Then we get in bracket Q1 over R1, Q2 over R2 plus Q3 over R3. Are you understand? Because we have total 3 charges in this. So we are taking here 1 over 4 pi epsilon naught. This is your QA over RA. Okay, sorry, not RA. One second. We should draw a diagram first, I think. One second. Look at here, please. This is your point P. You can take here your first charge is QA at this position, and the second charge is QB, and the third one is Q3. And when you join all of these charges to the point P, you get like this. Okay. And what will be your position vector QA to the P? You can write here R AP. Okay. And this is your R BP. And this is your R. This is your C, right? CP. Are you understand, Nawal?
Yes, sir.
Okay. Matthew, this picture is clear?
Yes, sir. Clear.
Okay, good. Similarly, we can write, sorry, this R can be written, this is your RAP. Okay. Similarly, this is your QB over R of BP and QC over R of CP. Okay. Then in the next part, you can write 1 over 4 pi epsilon naught. And this is your QA. And what is your RAP? RAP can be written as RP minus RA. Are you understand? From the concept of position vector, like this, you can look at here in this equation. If your position vector is RQP, then first of all, you should write R of P, I mean, of the last terms. From last term, you should subtract the previous term, okay? RP minus RQ. Are you understand, Nawal?
Yes, sir.
Okay. And now similarly, we are taking here RAP is equal to the RP minus RA plus QB over RP minus RB plus QC over RP minus RC. Okay. It's okay or not? It's clear?
Yes,
Clear?
sir.
Good. In the next part, sorry, in the next step, we can write 1 over 4 pi epsilon naught as 9 into 10 raised to the power 9. It's clear? What is your QA? QA is 1 into 10 raised to the power minus 6 over. What is RP? RP is your this minus of I. Sorry, this is very big equation. So first of all, note it down till here. Okay, then the remaining part we will solve on the next page. Are you clear? Note it down please till here. Yeah. It may take a big space. Have you noted it?
Yes.
Nawal, it's
Yes,
done.
sir. Yes, sir.
Okay, good. And now we are going to write this equation again on the next page. Okay. And this is your 1/4 pi epsilon naught QA RP minus RA plus QB RP minus RB plus QC RP minus RC. Okay, this is your equation here. Now, let's put all of, 1 second, because all of the values are written here first. Yeah. 1 second, please. Yeah, what is your, this is your equation. Now, please put all of the values. V is equal to 9 into 10 raised to the power 9. What is your QA? QA is 1 into 10 raised to the power minus 6 over. What is your RP? RP is minus I cap plus 2j minus of K. Okay? Minus. Are you understand here? Minus RA. What is your RA? RA is 0 totally. Okay. So I think if it is 0, then we can left it at this here. Okay. Plus QB. What is your QB? QB is minus of 2 into 10 raised to the power minus 6. Minus 2, 10 raised to the power minus 6 over RP. RP is again minus I cap plus 2j cap minus K cap minus RB. What is the value of RB now? RB is minus I cap plus 2j cap plus 3k cap. Okay. And the third one is, sorry, I am writing the third part here. This is your QC. What is your QC? Minus 1 into 10 raised to the power, 1 second, please. Let me mix here. Yeah, minus 1 into 10 raised to the power minus 6 over RP again minus I cap plus 2j cap minus K cap. Okay, minus. In bracket, we can write RC. RC is 2I cap minus J cap plus K cap. Nawal, it's clear. Nawal and Matthew. This equation is clear.
Clear, sir.
Okay. Because we have okay, put it all of the values given in your question. Okay. There is nothing from outside. Okay. And now in the next, we can write, 1 second, because it can mix. I am going to change the colors first. Yeah, in the next, V is equal to 9 into 10 raised to the power 9 and 10 raised to the power minus 6. From all of these three parts, you can take as a common. Okay. Then what is in your bracket? 1 over minus of I cap plus 2j cap minus of K cap. And now this is your minus 2. If it is minus 2, then you can take minus here, minus sign, because plus and minus after multiplication you get minus again. This is a 2, and now put all of the values after multiplication of sign in the bracket values. You get I cap plus 2j cap minus k. And now please see carefully on the screen, Nawal and Matthew. When this negative sign multiply with this minus I, then what you get? Nawal, after multiplication, this negative sign and this negative I, what do you get? I think you get plus I cap. Are you understand or not? Hello. Are
Yes,
you
sir.
understanding or not this point?
Yes, sir, I got it.
Okay. And similarly, when this when this negative sign will multiply with plus 2j, you get again minus 2j. Okay. And similarly, you get minus of 3k. It's clear? And now, once again, you have minus 1 here. If you have minus 1 here, then this minus sign and this plus sign after multiplication, it will be minus again. And 1 over minus of I cap plus 2j and minus k. And now again multiply this negative sign into this bracket values. You get minus of 2I cap plus of j and minus k. Are you clear, Nawal and Matthew?
Yes, sir.
This is your bracket values. Okay. Hence, in the next part, V is equal to 9 into 10 raised to the power 10 raised to the power 9 and 10 raised to the power minus 6 will be 10 raised to the power 3. This is your 1 over minus of I cap plus 2j cap minus of k cap minus 2 over this minus I will cancel from this minus sign and 2j will cancel from 2j, and now you have minus k and minus 3k. Finally, you get minus 4k. Are you clear? Are you clear, Matthew?
Yes, sir.
Nawal, it's clear or not?
Yes, sir.
Now, similarly, you can take 1 here, and now minus I and minus 2i. What will be your minus I and minus 2i? It will be minus 3i cap. Okay. And then 2j and plus j will be plus 3j, and minus k will be minus 2k. Okay. Now your equation is small in this step. And now you can take as a magnitude all of these values, 9 into 10 raised to the power 3. And now this is 1 over root of, what is your magnitude of I cap? This is your minus 1. So you can take minus 1 square plus magnitude of j cap is 2. It's your 2 square. And similarly, minus k, you can take minus of 1 square. Okay. And now minus of 2 over minus of 4k can be taken as minus of 4 square minus 1 over minus 3. You can take minus 3 square, and j, magnitude of j is plus 3. So you can take 3 square, and magnitude of k is minus of 2 square in root. Okay. Note it down till here, please. And now one more step is remaining. Only one more step. Have you noted it?
Yes, sir.
Nawal, it's done?
Yes.
Okay, good. Again, I am erasing this equation. And now, after this equation, you can write V is equal to 9 into 10 raised to the power 3. In bracket, it is 1 over. Now, can you tell me after squaring minus 1, after squaring, you get 1 plus 2 square is 4 and 1 minus 1 square is 1. Okay, in bracket. Similarly, minus of 2 over minus 4 square is root of 16 and minus of 1 over, you can write in bracket again, one more step. Minus 3 square is 9 plus 9 plus 4. Okay. Similarly, again, you get 9 into 10 raised to the power 3. 1 over, this is your root of 1 plus 4 plus 1. This is your root of 6. Minus 2 over root of 16 can be taken outside. From the root, you get 4. Minus 1 over 9 and 9, 18, 18 and 4. This is your 22. Okay. This is your 22. In the next step, this is 9 into 10 raised to the power 3. 1 over root of 6 minus 2 to the 4. You can write 1 over 2 minus 1 over root of 22. This is your final answer, okay, of this question. It's clear, Nawal? Matthew, it's
Yes.
clear or not? Any issue in this
Yes, sir.
question? Is there any issue in this question?
No.
Good. All of you want to solve one more question of different types? Hello? Hello? Matthew and Nawal, all of you want to solve one more question of different types?
Yes, sir.
Okay. Now, please note it down. This is a good type of question, okay? And such type of question is mostly asked in your final examination. I mean, in the board examination of CBSE. Note it down, please. Two charges two charges, 3 into 10 raised to the power minus of 8 coulomb and minus 2 into 10 raised to the power minus 8 coulomb are located 15 centimeter apart. 15 centimeter apart. Okay. And now at what point on the line joining the two charges the two charges in the electric potential at what point on the line joining of the two charges is not in, this is your is the electric potential is 0. Okay. Hello. Yeah. At what point on the line joining of the two charges is the electric potential is 0. Okay. Now, how can you solve it? Nawal, can you tell me please your idea behind solution of this question? Nawal,
Yes.
can you tell me what is your perceptions of okay solution for this question?
I'm not sure.
Not sure. Okay. And one more. Matthew. All of you can open your camera, please, if possible. Hello. It's possible to open all of your camera?
No, sir.
Okay. So
they've given Q1 and Q2, right?
yeah. Exactly. You can take Q1 and Q2 and
R is also given.
R. Exactly. R is also given. Yeah, good. Your Q1, you can take it as Q1. Nawal, please look at here carefully. Okay. Your Q1 is given. Just 1 second. First of all, we are going to read this question carefully. Two charges. Okay. Two charges. This is your first charge and this one is your second charge, are located at 15 centimeter apart. Okay. You can draw like this. This is your two charge. Okay. And both of the charges are at 15 centimeter, right? You can take here, this is your charge A, which is your Q1. 1 second. This is your Q1, can be taken as 3 into 10 raised to the power minus 8 coulomb. And this one is your Q2, which is your minus of 2 into 10 raised to the power minus 8 coulomb. Okay. And it is located, sorry, these two charges are located at 15 centimeter apart. Okay. So you can take this separation is of 15 centimeter. Nawal, now it's clear or not?
Yes.
Okay. This is your 15 centimeter. It is saying that at which point of the line joining. What is your line joining? This is your line joining. Okay. I mean, this is the line which joins these two charges, Q1 and Q2. Are you clear? That is said to be the line joining. Okay. The two charges, electric potential is 0. Now, can you tell me what is the probability? What is the probability, okay, of 0 potential? Is it is possible in between Q1 and Q2 or beyond Q1 and Q2? I mean, in between 15 centimeter or beyond 15 centimeter? Nawal, where your potential may be 0, I think. Okay. Because exactly we are not clear that where your potential is 0. Okay. So I am telling that where the possibility, okay, of 0 potential in between 15 centimeter or beyond 15 centimeter. Matthew.
Yes,
Matthew.
sir. Yeah,
where
yeah.
your potential may be 0, in between 15 centimeter or beyond 15 centimeter. Can you tell me?
It's beyond. I mean, sorry, in between.
In between. Nawal,
Yeah.
can you
Yes, sir.
tell me
I
where
don't
it is
know.
possible?
I don't know, sir.
You don't know. Okay, and don't worry. Okay.
It's because Q1 and Q2 have two different magnitudes, so I
No,
think it
no,
will
no,
be.
no, 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 no. Just look at here. It may be possible in between as well as beyond 15. Are you understand?
Yes.
It may be possible in between 15 as well as beyond 15. Okay. We are taking case 1 first. Okay. And we are going to solve taking in between 15 centimeter. Okay. And then we will solve beyond 15. Are you clear?
Yes, sir.
First of all, we are going to choose any point at here. And this point is your point P, you can say. This is your point P. We can assume that at point P, your potential is 0. Are you okay? We can assume that your potential at point P is 0. Then first of all, we should calculate the separations from Q1 and Q2 to the point P. Okay. And now we are going to choose here. We are taking this separation. We are taking this separation of 15 minus x, and this separation is of x. Are you clear from these two values, 15 minus x and x? Nawal, it is clear?
Yes, sir.
Because after adding 15 minus x plus x, you get again 15, okay? Which is your value, okay? So I think it is clear. And now we are going to calculate zero potential. Are you understand? We are going to calculate zero potential. So for doing like that, we can write potential at P is equal to potential due to A and potential due to charge. One second. Yeah, potential due to charge 1 and potential due to charge 2 should be 0. Are you understand? And now what is your V1? The potential due to charge Q1 at point P is your V1. V1 can be written as K Q1 over. What is your R from Q1 to P? From Q1 to P, you can take here, this is your R1 and this is your R2. Are you okay? So you can take here R1 and plus K Q2 over R2, which should be 0 because we are solving for zero potential. So we are continuously taking here equal to 0. Okay. This is your K. One second. At point P, V is equal to, sorry, both of the charges, yeah, both of the charges are, yeah, no issue, because one of the charge is in positive and second one is negative charge. Okay. Now, you can write here minus of Q2. You can write here minus of Q2. Are you understand, Nawal, why we are taking Q2 as minus?
Yes, sir.
Nawal, are you understand the reason
Yes, sir.
behind negative sign for Q2. So finally we get K Q1. What is your Q1? It is your 3 into 10 raised to the power minus 8 over R1. What is your R1? R1 is 15 minus X. Minus. This plus and minus will be minus K. What is your Q2? Q2 is 2 into 10 raised to the power minus 8 over X. Should be 0. And now this is your K. 3 into 10 raised to the power minus 8 over 15 minus X, which is equal to, okay, we can write equal to because after transferring this value from left hand side to the right hand side of equal sign, your negative sign will be positive and you get K 2 into 10 raised to the power minus 8 over X. Are you understand, Nawal? Now K will cancel with K. 10 raised to the power minus 8 with 10 raised to the power minus 8. You get 3 over 15 minus X is equal to 2 over X. And now you can multiply, you can do your cross multiply. This is your 3X is equal to 15 minus X into 2. You get 3X is equal to 15 into 2 will be 30. And 30 minus 2X. And after calculation, you get transfer this 2X from right hand side to the left hand side. You get 5X is equal to 30 or X is equal to 30 over 5. Finally, you get X is equal to 6 centimeter. Are you clear, Nawal?
Yes, sir.
What does it mean? Matthew.
At 6 centimeter,
Exactly.
relative potential is
Try
0.
to understand here. This X is equal to 6. What is this? This value of X represents this one. This value is 6. I mean, at 6 centimeter, yeah, from Q2, your potential is 0. Or you can say, at what is your R1? Now, what is your R2? This is your R2 especially, right? You can look at here. For R1, you can calculate 15 minus X. You can write 15 minus 6. This is your 5 and 4, 9 centimeter. I mean, at 9 centimeter from Q1, okay, your point P is lying here. Are you understand? Nawal, are you clear
Yes,
now
sir.
or not? It is clear or not?
Yes, sir.
Note it down, please. Okay. 9 centimeter, okay, from charge Q1. And this is your 6 centimeter from charge Q2. Note it down. I mean, it is clear that there is a point in between 15 centimeter where potential is 0. And we have already calculated it. Are you clear? Okay.
Yes, sir.
And now, is there any other possibility where your potential is 0? Nawal, is there any other possibility where your potential is 0? You can look at, okay, you can write here at point P. We are solving this calculation for point P, okay? Matthew, is there any other location where your potential is 0?
No, sir.
Yeah, it is. Okay, first of all, note it down, then we will calculate it again. Have you noted it? Now, all this question was interesting or not?
Yes, sir, it was.
It is a very suspensious questions, right?
Yes, sir.
Matthew,
Yes.
are you enjoying this question or not?
Yes, it's fine.
This question is full of suspense, okay? Have you noted it?
Yes.
Good. Nawal, it's done?
Yes, sir.
Okay. And now, we are going to consider that it may be possible. It may be possible. Your potential should be 0 beyond 15 centimeter also. Okay? Beyond 15 centimeter also. Now look at here. How can we find out? We are choosing one another point on the line joining of Q1 and Q2 at here. And this point is point, Q is denoted for the charge. You can take here point M. Okay? Are you clear? We are considering any point at point M. Okay? And you can join this from here. And now, all of you can remove these assumptions as well, okay? Because there is no requirement. And now, can you tell me, we can take here, this is your separation of Y. We are taking this is Y separation, okay? Are you clear? Then, can you tell me, this is your Y distance from charge Q2. Are you clear? I means the separation from M, separation from Q2 to the M is Y. Okay. And then what will be the separation from Q1 to M? Nawal, can you tell me please? What will be separation from Q1 to M?
So what did you ask?
Sorry.
What was the question?
What will be separation from Q1 to point M?
15 plus 1.
15 plus Y. Okay, good. This is 15 plus Y. It's okay. And now again, we are going to solve it. We are going to calculate the potential is 0 at any general position M. Okay, this point is not cleared. I mean, what is the exact separation from Q2 and Q1? And we are going to that exact position. Okay, so we are going to solve now for at point M. Okay, so potential at Y is equal to VA plus VB, which is equal to 0. What is your VA? Again, we can take K, Q1 over 15 plus Y. I am taking directly. Are you clear? Are you clear or not? Hello?
Yes, sir.
Clear, sir.
Well, it's clear. So, and now for VB, your charge is negative. So we are taking directly a negative sign. This is your K, Q2 over Y. Okay, and finally it is 0, and you can write again k q1 plus over 15 plus y minus k, sorry, equal to k q2 over y. K is cancelled with k. One second. You can put all of the values of q1. What is your q1? Into 3 into 10 raised to the power minus 8. And what is your value of q2? Q2 is 2 into 10 raised to the power minus 8. 10 to the power minus 8 minus 8. Both will cancel each other. You get 3 over 15 plus y and 2 over y. Now again cross multiply. 3y is equal to 2 into 15 plus y. 3y is equal to 13 plus 2, 30 plus 2y. You get 3y minus 2y is equal to 30. Now 3y minus 2y is your y. I mean y is your 30 centimeter. What does it mean? It means that this is your 30 centimeter. Y is 30. Okay. I mean from charge Q2. This is the separation of point M. Are you understand? Matthew? Nawal? All of you understanding?
Yes.
What does it mean? Your y is equal to 30. This means that your Q2 is, your point M is 30 centimeter away from Q2. Are you clear? Then what will be the separation from Q1? It will be 15 plus y, which is your 15 plus 30, and you get 45 centimeter from Q1. Are you clear? Are you clear or not?
Yes, sir.
This means in between 50 centimeter and beyond 15 centimeter, your potential may be 0. Not maybe, now we have already calculated your potential is 0. Possible. Okay, it's possible here. But remember that in such types of question, because it is a big suspense in this question where he want to where he is asking for the 0 potential in between 15 centimeter or beyond 15 centimeter. Are you clear? So while solving such types of questions, okay, either you can calculate at point 1, anyone, okay, at any one of the point, either P or M. If you have calculated correctly, you will get, okay, you will get total number, okay, without any deduction. Are you understand or not?
Yes.
Hello? Yeah. You will get total marks, complete marks on these questions, okay? Any one point you can calculate, okay? There is no any requirement to calculate at the 2 different points, P and M, okay? Anyone at the point, because I was solved here for 2 different points just for your convenience, okay? Just for your, just for build your understanding. Are you clear or not? But it is not required to calculate 2 different positions, okay? Have you noted it? Have you noted it? All of you have any other class after this or not? Nawal and Matthew. All of you have any other class after this?
Sir, I have a test tomorrow, so I have to study for that.
You have a class after this class, right?
Yeah.
And Nawal,
Yes, sir.
have you any other class after this or not?
No, but I have an exam tomorrow.
Okay. So what is better for here, because we have 15 minutes, and if you go to the next derivations, then it will not complete within 15 minutes. Okay. Uh, it may take 20 minutes. It's possible or not, all of you? Matthew? Matthew?
Yes, sir.
It is possible. I think your class will over around uh,
6:30. I mean, third. Yeah.
yeah,
Yeah.
I mean hardly 5 to 10 minute delay. Is
It
there
is not
any
a
issue?
problem, sir. I have a test tomorrow. That's what. Not class. I
Okay,
have a
you
test
have a
tomorrow.
test. Okay, all right. Then what we can do here? But let's try it. Okay. Now, please write down it fast. Electric potential of dipole. No. It's not possible to write here. Okay. Don't worry. Please note down one more questions. We have a rectangular shape body at all of the vertices. This is your plus E, this one is your plus 4E, and it's your E, and this is your minus of 2E. It's okay. And this separation is of A. And we have any other point E here. And the separation is your A by 2. This is your A by 2. Your question is calculate in the first part electric potential at O and E, and the second one work done in carrying an electron from O to E. This is your O. This is your O. Okay. And now please note it down fast. Okay, and we'll go to the solution. And write down one more questions first. This is your question number 1, and in this there are 2 different parts. This part, okay, we will solve in the class, and this part is for your homework. And one more question I am giving to all of you for the homework purpose. Note it down. There are 2 different charges, Q1 and Q2. 2 different charges, Q1 and Q2, are given here, plus E and minus of 4E. At what point, note it down, at what points, on the line joining the charges electric potential is 0. Okay, this is for homework. Okay. Your electric potential is 0. Note it down, please, all of the questions. Okay, then we will go to the solution. Have you noted it?
Yes.
Good. And now we are going to solve this part. Okay, first. Now, if all of the sides are A, then you can understand easily all of these vertices, all of these separations will be A by root 2. Are you clear? Nawal, are you understand it?
Yes, sir.
All of these separations will be A by root 2. And now we are going to calculate potential at O. Okay. So please note it down. Potential at O is VO is equal to 1 over 4 pi epsilon naught. What is your Q? For this charge, it is your plus E over A over root 2 plus for the next charge, it is 4E over A root 2 minus, because your next charge is in negative sign. So we are taking here negative as A over root 2 and this one is your minus of 2E. So it is 2E A over root 2. Okay. From all of this part, you can take A over root 2 as a common. 1 over 4 pi epsilon naught A over root 2 in bracket. E plus 4E minus E minus 2E. E and E will cancel each other. Plus 4E and minus 2E will be 2E. So you get V naught root 2. Sorry, 1 second. One more step we will take here. V naught 1 over 4 pi epsilon naught A over root 2 in bracket. This is a 4E and minus 2E will be 2E. Finally, you get 2 root 2E over 4 pi epsilon naught. This is your V at O because we have transferred this root 2 from denominator to numerator. Okay. Note it down, please. Are you understanding or not, Matthew?
Yes, sir.
Nawal, it's clear?
Yes, sir.
Okay, good. Note it down, please. Is there any issue? Okay, feel free to ask me. There is no any issue. Okay. But your concept should be clear. It doesn't matter. Okay. It doesn't matter how many time it is taking. Okay. Nawal, are you clear?
Yes, sir.
Okay. You can ask me any question freely. Okay. At any time. We will discuss on that question if you have any issue. Note it down, please. It's noted or not? Matthew?
Done, sir.
Matthew, it's done.
Yes, sir.
Nawal,
Yes, sir.
it's done or not?
Yes,
Okay, so we are going toward this class today, and from the next class we will continue to the electric dipole, potential due to the electric dipole at any general point. Okay, in the next class,
Okay.
right? And it is one of the important heading. So I have skipped today because it will take around 30 minutes for for the calculation as well understanding. Are you understand? And we will try to solve
Yes,
2
sir.
to 3 questions on the behalf of it. And then we will move to the electric field and gradient potential and some questions. Okay, this is your next class topic. And then the equipotential surface. After solving equipotential surface, your electric potential will over. I hope in the next class your electric potential will finish. Okay, and we will enter into the electric potential energy. Okay,